Today we are going to talk about cube root functions, and there's three TEKS we're going to look at. We're going to look at the parent function attributes of a cube root function, transformations of the cube root functions, and we're going to look at domain and range of the cube root parent function and of the transformations. So first we're going to start with the cube root parent function. The equation for the cube root parent function is f of x equals the cube root of x. And this is what the parent function graph looks like. If you look at it, it goes through 0, 0, and this does have rotational symmetry, but this is the cube root graph. So let's look at domain and range written in the three different variations. So we have interval notation. So domain is going to be my possible x values. So domain is my possible x values, while range is going to be my possible y values. So my domain is going to be negative infinity, because it's going to go forever to the left, to positive infinity. So as interval notation, we write this with parentheses. Parentheses signify that we can never touch infinity, but we are approaching it. Inequality, we can write negative infinity is less than x is less than infinity. Now it's less than, not equal to, because again, the parentheses and the less than symbolize that it's never actually going to touch infinity. And in set builder, we're going to write x such that, and there's a couple different things you can write here. We can write that x equals all real numbers. Okay. So the range, how low is this graph going? The graph is going to actually go down forever. So on all cube root functions, our domain and our range are going to match. We have interval notation. Now the difference with our inequality is that instead of x, you put a y. And the same thing with the set builder. Y such that y is equal to all real numbers. So let's discuss transformation. So we know that this is a cube root of x. So the cube root is always going to be there, and you have to have an x underneath your radical. If you have an a value, this will be in front of your radical. This will cause a vertical stretch if the absolute value is greater than 1. A vertical compression if the absolute value is between 0 and 1. And if it's a negative, the negative causes it to reflect over the x-axis. The b value. Notice that the b value has to be underneath the radical. Now the b value, you can be touching the x, but the b has to be in front of the x. It's being multiplied by x. This will cause a horizontal stretch or a horizontal compression. And if this is negative, this graph will reflect over the y-axis. Now the h. Notice that the h has a negative in front of it. So that means that any number we see here, it's actually the negative number of it. So if this says -3, then h is really a +3. And the h value moves the graph left and right. And the k value is going to shift the graph up and down. If you see a positive here, it goes up. If you see a negative, this goes down. So let's look at some of these questions. What do these numbers do? This number is in front of the radical. And so if it's in front of the radical, this is my a value. This 2 is underneath the radical, and we see a +2. But remember, we actually have to change the sign because it's a minus x minus a -2. So our h is really a -2. There is no b, there is no k. An a value of 3 means vertical stretch of 3, and an h of -2 means left 2. So the most common mistake there is forgetting to change this sign. This number right here will always change signs, and so once you change the sign, then you can decide left or right. So right here, this is in front again. This means that my a value is a 1/3. And this is at the end. This is after the radical. Notice that line does not cross it, so this is actually a k value, and the k value is -1. And I don't have an h and I don't have a b, so there's nothing happening there. An a value of 1/3 means it's a vertical compression of 1/3. A compression means it's going to get closer to the x-axis. And as k is a -1, this means that this graph would actually be translated down 1. Okay, so make sure you see the differences between where your H is located under the radical and the K is located after the radical. So we have a couple more here. So this 5 value is underneath the radical, and so this is your B value. Now, because I have B and H under, it's been a while since we've done these, but remember, if we have a B or H, B and H, we're going to have to factor out that 5. Okay, so when we factor it out, we divide both terms by 5, and since that can't be divided, we're going to leave it like that. Now, both of these terms are underneath the radicals. This one's a little bit trickier. So the 5 is a B value. So B is 5. But what's tricky here is that this is going to be a horizontal compression. And whenever we deal with horizontals, we're always going to take the reciprocal of the horizontal compression. So it's a horizontal compression of 1 over 5. An A, I don't see an A. I don't see a K. My H value is what's inside the parentheses with the X. It has to be here, but H will always be added or subtracted to the X. So remember to change the sign there. So this is going to be a positive 3 over 5. So the graph went right 3 over 5, or you could say right 0.6. Okay. The second question, okay, I see actually 3 different numbers. I see a 1/3 for A. This is going to be a vertical compression of 1/3. For the B value is 1, which means there is no horizontal translations. Now for the H value, H is underneath the radical, but this is always the opposite of what we see since we're actually subtracting it. So H is really a -2, so this graph is going to the left 2. And the K at the end is -1, and -1 signifies that this graph is actually going to be shifted down 1 unit. Now by looking at a graph, so right now we're given that the parent function graph, and we are going to look at how the translations affect the graph. So let's look at this. We have an A value of 3. A value of 3 means vertical stretch of 3. -2 under the radical is an H value, but I have to change the sign. So H is really a +2. So this graph is going to shift to the right 2. And the graph is going to shift up 1, and the K value is a +1. So when I graph this, I like to think about the origin first. And so my origin is right here. And so I'm going to move this point to the right 2 and up 1. So this centerpiece of my graph is going to go to the right 2 and up 1. And that A value can be used to help me plot my first point. Okay, so that A value is a 3, which means it's stretched. So from this point, I can use it one time to go up 3 and over 1. So up 3 and over 1, and down 3 and over 1. I know it looks like a straight line, but it's not. So we're going to curve, curve, curve. And so it's not a perfect graph, but notice that it is completely stretched out. And notice that my centerpiece did move to the right 2 and up 1. The domain and range for cube roots never change. The domain and range are always going to be negative infinity to infinity. And I'll go ahead and write those in interval notation on this one. Okay, so the next one, let's discuss that. The next one, I have an A value of 1/2, which means a vertical compression of 1/2. My H value will always change, so this graph is going to go left 3. This is my K value of -2, so the graph is going to go down 2. Okay, again, when I graph this, I like to think about this origin. Where is it moving? It's moving to the left 3, and it's moving down 2. So my first point I'm going to plot is -3, -2. Now this graph has a vertical compression of 1/2. That's up 1 over 2, down 1 over 2, and this does curve. Okay. Now this graph is actually a vertical compression of the parent function. Remember that domain and range don't change, but I'll go ahead and write this one in inequality notation just so we can practice the both notations. Hopefully this video helped understand transformations of a cube root parent function and the domain and range.